this. In any given environment, any given area, I just put a square or a rectangle because it is what it is, right? But the shape could be the shape of the United States. It could be the ocean, the Atlantic Ocean, Pacific Ocean. It could be any space where there's life existing. What do you think is going to be the largest portion of life in that space? Plants. Why do you think plants are going to be the largest portion of life in that space? Why? You're right. The question is why. Can someone answer that? Yeah.
Is it because of all their available resources?
Kind of. Why do you think the answer is both simple and so simple that it's hard to see? Why are plants always going to be the largest component of any environment? Yeah. Or not, let me rephrase that, sorry. Not necessarily plants, but why are producers going to be the largest component of any environment? Yeah.
Because they produce the food.
They produce the food. And can you have more animals than you have food? No. Not for very long, because very soon what happens? They start to die. So very good. So producers are the first, have to be the largest component of any environment. Well, what eats producers? A consumer is correct. Is there anything that eats consumers? Yeah. Yes. Is there anything that eats them? Yeah. Yes. So we call these guys at the bottom, these are producers. And on land and in most places on earth, they're plants or some kind of photosynthesizing bacteria or what have you. So these obviously, at least I hope it's obvious now, get all their energy from the sun. And they get their carbon, where do they get their carbon from?
Isn't it the other animal?
CO2. Producers get their carbon from the air. The CO2 in the air. And where do they get their nitrogen from? They get it from bacteria. I should say they get it from the soil. And they get it from nitrogen fixing bacteria that originally got it from the air. Correct? And where do they get the water from? The 5 things that they need, right? Water from the ground through their roots, right? With the help, all of this, and they get minerals, right? Also, because they need phosphate, don't they? They get the minerals and the phosphates from the ground. These guys here are helped with the help, often with the help of fungi. Correct? Symbiotic mutualistic. Right, so they help each other. All right, that's kind of a summary of everything we talked about thus far. Those are the producers. Now, what are we going to call, since all of these guys, after the producers, they all consume, they all eat, how are we going to differentiate between these consumers and then these consumers and then these consumers?
Aren't there like primary?
That's right. We call them primary consumer. We put the little prime, little secondary consumer, and tertiary consumer. So what's an example of that? Well, you can think of, a mouse eating seeds. You can think of the snake eating the mouse. Then you can think of the hawk eating the snake. So my question to you is, where in which of these primary, producer, primary, secondary, tertiary, which has the most amount of energy? The producer, I hope you think. I know you cut out the producers in your mind. I understand that. But, I meant producers. Yes, but you're right. The lowest one, right? The largest portion. So this block not just looks at the most amount of mass, right? So you'd expect to see the most amount of mass in the producers. You'd also expect to see the most amount of energy in the producers as well. And the second, primary consumers would have the next most amount of energy and mass, and snakes and the hawks. Number-wise as well, right? You wouldn't expect to see more hawks than mice and snakes, right? Because how could they eat? Does that make sense? Yeah. So we call these things, these levels, these are levels. This is level one at the producer level. We call these things trophic levels. So you got this level one, or the producer level, then 1, 2, 3. Does that make sense? Now, there's a rule when you take the energy from the producer and go to the next level. Every time you go up a level, you lose 90% of the energy and matter. Most of what you eat comes out in poop and heat. You lose it. So it turns out that the rule is 10%. You should know that. So about every time you switch, why did it do that? Every time you move, something takes only 10% goes to the next level. So every time. So if you have 100 units of energy at the producer level, then you only have how much at the mouse level? And how much do you have at the snake level? And how much do you have at the hawk? Right? So every time you lose not 10%, you can only take 10%. That's as efficient as biological systems are. We lose energy and mass through poop, and energy through heat, right? Because it takes energy to break things down. So we can only take 10%. So we're very inefficient. So think about that as you're doing this case. Okay? All right.